Okay, continuing on homework 2, part C, we already got all of our equations. Now we're going to plug it into Python and get an actual answer. So we of course start by importing numpy as mp, and we want to import scipy as sp, and then we want to add in all of our variables and what we know. So we have r1, which is equal to 1. We're going to have our thickness, which is equal to 0.01. We're going to have R2, which will equal R1 plus T, and then we're going to have an area, which is equivalent to pi R1 squared. We're going to have a height, which is 5, there we go. And then we're going to have a volume, which is going to be equal to pi, say R2 squared minus R1 squared times h. And then to include the end cap, we're going to add pi times R2 squared times the thickness of T. We also are going to have density of steel, which is equivalent to 78, where is it? 50. And then we're going to have our density of water, which is equal to 1,000. And then we'll have our temperature, which is 298. We'll have gravity, which is 9.81. And a regular R for the gas constant equation, which is our gas constant means, it's for the equation, sorry. No, 314, there we go. And then our initial pressure, which is going to be 101, 325 pascals. Those are all of our variables that we're going to have. So now we're going to just start defining and figuring out, plugging in all of our equations and stuff. So we're going to have a pressure equation, which is going to be equal to the density of water times G times D minus Z. And then we're going to have, do this, D comma Z is equal to the vector, and then we'll go here like that. We're going to have the density of air, which will be equivalent to P times M times the mass of air. That's what we need. And then that will be divided by R times T, because that's our, rho equals P M air over RT. And then we're going to want to actually go back up here. We need to identify what M air is, which is 29 times 10e to the negative 3. That's the molar mass of air, which is what we're going to need. And then within this, we are going to want to write out our equations. So we're going to plug in equation 1, which we'll call equation 1, which is going to be equal to the density of steel plus the density of water, and all of that times V, and then minus the density of water times the area times H minus Z. and then we're going to add density of air times the area times h minus z. That's going to be our equation 1, and then equation 2, we're going to have pi times p1, sorry, p1 times h minus rho density of water times gravity times d minus z times h minus z. And then we're going to return. We want an array of equation 1 and equation 2. And we're going to have a guess in here, just something for the array. A dot array of, we're just going to say 1, 0.05, like that. And then we're going to say our solution is equal to sp.optimize.root of f comma dz guess. So to get our answer, just type in f sol.x and run it, and those are the values we get.